You can run with it.
Hey, my name is Walter Hager. I know a couple faces here, not too many. I know you, right? From previous meetings. Anyways, right now I work for FedEx. Today I've been doing software development for about 25 years or so. I have a background in mathematics, so this is kind of stuff that I like doing. Tonight I'm going to be talking about artificial intelligence and an algorithm that really came to my attention called NUPIC. I don't know if anyone ever heard of NUPIC. It stands for Numenta's platform for intelligent computing. Basically, it was founded, it's also known by two other names. Well, that's the company name. They have something called, they call it the cortical learning algorithm, and also the hierarchical temporal memory. And basically it was founded by a person named Jeff Hawkins. I don't know if you know Jeff Hawkins. He's the former founder of Palm Pilot and Palm Pilot and Handspring. So one of the early adopters of that. And he jokes around that he was like an actor that waits on tables because he couldn't get funding for what he really wanted to do, so he ended up working in the Palm Pilot space and making money so he could fund his real true passions, which was basically studying the human brain and then trying to mimic that architecture. He talks about going to school at Cornell, graduated in '79 at Cornell, and then he tried to do modeling of, computations and basically modeling the human brain, and there was absolutely no interest in doing it that way. The head schools at Cornell, MIT, and Stanford and Berkeley had their own ways of doing things, and they didn't want to listen to his ideas. And he tried to make up a program, and he spent a couple of years as a graduate student basically pursuing his own curriculum and taking classes in neuroscience and computing, but there was nothing there that really was focused at what he was interested in. He couldn't get funding, he couldn't get a professor to take on his research and his work and interest, and he ended up kind of leaving the field and becoming an engineer. I think he has, I think, a bachelor's degree in electrical engineering, and so he ended up basically using that to design the products put out by Handspring and handhelds. Everyone knows that. Everyone knows that what handhelds are. Anyways, but after he raised he raised money, and he decided, okay, I'm going to go back into neuroscience, and I'm going to do what I want to. And I think he formed like a research organization out of Berkeley or Stanford. I think it was a neuroscience lab there. And in the course of doing that, and he had the freedom to basically develop and also research how to actually go and design, basically reverse engineer the brain. So the first piece of knowledge that we'll talk about is that, the neocortex is the top layer of the human brain, or the mammalian brain actually. But the neocortex is about the size of a tablecloth, so it's about 1 square meter and about 2 millimeters thick, and it's all rumpled up and put there on top of your other brains. And the other thing is, in the way that we model it, the sensors actually come out of the sensors really come out of the bottom here, and so they really, you have wires and it's all connected through the spinal cord. It goes out to all your senses, and so the picture is kind of opposite of what it looks like. And so, anyways, basically, if you notice, if you look at the neocortex under a microscope, you see that it's basically broken down into 4 layers. But let me back up. So this is this hierarchical temporal modeler, or the cortical learning algorithm, is basically a biologically inspired model for data representations. And what it tries to do is identify patterns in time and in space. So that's kind of a summary of this algorithm and the stuff I'm going to be talking about. Now this stuff is really tough, so I've been looking at it part-time for maybe a year, maybe 2-3 hours a week here, 2-3 hours a week there. So I don't understand it as well as he does. I mean, he's got a research staff, and he he's been doing it for at least 20 years or so, and on top of his work in grad school. So if there's going to be things I don't understand, so don't beat me up too much. All right, and I was going to show you. So I have some slides here. I'm just going to show you a picture, and the picture is from one of his presentations, and the picture is basically showing the structure of the human brain. So we all like looking at pictures. Oh, this is like a dendrite. This is basically like a nerve, okay? And so he uses terms from biology to describe how he reverse engineered the human brain and basically designed this architecture. And so basically, here's his breakdown pictures, and it'll be overkill for me to try to explain everything, and I'll probably make too many mistakes, and the doctor over there will throw rotten vegetables at me. So I'll give you a higher level picture, and basically, that's like a schematic representation of what the neocortex looks like, and basically you can simulate the same model in hardware, in electronic hardware, by basically having a layer of nodes, and these nodes basically represent what is happening at each of these computational units. Okay? So let me just find that slide, sorry. So basically this is that picture. So over here, you see his data structure is basically, it's made up of 4 layers of nodes, and the bottommost layer was the one that basically has the sensors hooked up to it. And then there's 4 layers, and they're the data structures at each of the layers is almost identical, although they serve different purposes. And it's really the middle layer that we really, the higher we go up this hierarchy, the less and less we understand. But basically, so if you look at vision, okay, you have your sensors in your eye detect colors and things like that, and then the next layer up here looks for edges, and then there's sensors that detect edges, vertical edges, horizontal edges, slanted edges, and probably other types of entities, straight lines, curvilinear lines, and probably even other stuff. And I remember reading about stuff like this back in the 80s, so it was probably well known even at that time.
So how is this different from a neural net?
Well, okay, this is a kind of neural net. It is a kind of neural net.
It's hierarchical.
But
it's not like it's. Yeah. Sorry. Go on.
well, it is a type of neural net, but it's very specialized. But basically, let me just get back to what I said. So these are the sensor inputs. Over here are like probably over here are the edge detectors and things like that. And then up here are formulators of higher level concepts. And then finally, you have a high level thing that identifies things like words and other types of entities. So, and the other thing about them is that the human brain is very regular. People used to think that there were components of the human brain that were specialized to certain functions, but we're beginning to think that that's not true. It's all spread over, and in some ways people have noticed that it's possible to reteach people if they, like a good example is people have had nerve endings cut, and then doctors reattach the nerve endings, and then after it's been reattached, they cross their wires. And it's possible to reteach someone how to reuse their hands, even though the connections have been rewired. So basically, the mind learns and basically identifies this. So it's not as many genetically laid out as to the wiring. All this becomes learned behavior and learned knowledge. And it's basically represented in here. So, okay, so that's one thing. The other thing is that the nerve endings in this same pattern is true for all four senses. Okay, so whether it's smell, touch, hearing, or seeing, they're the same sensors that do this. So the biology is very generic, and then it becomes adapted by the way it's all integrated together. So he basically has this data structure, and so he over the last couple of years, he's open sourced a lot of this architecture and problems. I think fundamentally because, well, one thing, he wants to figure out what other applications are there to this data structure to real-world problems. So he's trying to find good fits for the problem. He's also open sourced the code, so one can take and download the code and do. He has a GitHub site. You just have to sign up and sign a license agreement that, you know, if it really becomes grand, it's his. Okay, it's licensed under the GNU GPL, the GNU public license, so that if you derive something with that, it becomes incorporated into the body of knowledge. What else? Oh yeah, one more thing I was going to say about these data structures. They find, and I'm thinking numbers, I mean this is probably there's million, I don't know how many cells are there that are sensor cells. You know, probably hundreds of millions, probably even billions. Anyways, another thing that he noticed is that there's only like a 3% connectivity between each, well, this node only connects to 3% of the nodes in this layer, and vice versa. So there's only a 3% connectivity, and that becomes useful in identifying shades of gray. So, and I can't get into this. I mean, this could be a 6-hour. If you go to YouTube, I have a couple quotes. If you go to YouTube, you can basically take a look at a whole bunch of videos that he and other people have that discuss this. So you basically just go out there and you start off by Googling Numenta and Hawkins, or even Numenta, and the most interesting thing that you go to first is this YouTube site where he has a whole bunch of presentations that he and his research associates made about this algorithm. And also he published a book in 2004 called On Intelligence. It was popular, you know, made it to, you know, at least the geek reading lists. I don't know if it made it to, you know, popular readings, but okay, and so he open sourced this code, and it's on a GitHub site. Over the last couple of years, people have migrated the algorithms to, I think originally most of them were in Python, and recently they just finished the Java migration, and they also did in parallel they did a C++ migration. And there's also interest in people migrating the algorithms to other languages. I think, you know, over time it'll become a kind of a problem, in that, you know, maybe some research will be done on these, and then the research isn't spread to other platforms and other technologies. Also, every year he runs a hackathon. Actually, now he's doing it 3 times a year. So he basically, the company is situated in Redwood, California, and so in October 17th of last year, they had a big hackathon where people went out there and spent the weekend trying to, you know, apply the algorithms and look for novel applications. There was a great deal of interest in like drones and robotics, and, you know, trying to get drones to basically fly around and maneuver through an obstacle course, and to basically teach themselves on how to fly. And basically they what are called the four omnicopters. You know, so there's a lot of demos on there doing that. And also they had one application that was actually a hackathon about 2 years ago that really came out interesting. Basically it was a classification algorithm for classical musicians, and I suppose you can do it for other musicians, but basically they would train it on like Chopin, and they would train it on Mozart, and they would train it on this and that, and basically be identified, okay, this music is endemic to Mozart, and then the algorithm would basically play pieces, it would basically compose music in the style of, Chopin, in the style of Beethoven. And, for people who aren't musically inclined, yeah, it does sound very much like that composer, this could be a missing piece. And also, I guess the other reverse thing is that, okay, if you find a piece of music, you can begin to figure out, okay, where was it influenced? Okay, it's influenced by Mozart, and you can see that there's certain idioms that are in that music that the algorithm can identify and find them in other music, so it can do matching. There's all sorts of applications that they're trying out. There's also, I think, the other thing is that the reason maybe they open sourced it. I don't know if you know Google. Google has a computation thing called DeepMind. Any of you heard of DeepMind? It's a company that they bought out of England about a couple of years ago. And they've been very secretive about it till about last year. And now they announced this to the offering, and so I think he doesn't have the money that Google does, so he's hoping to inscript and not a lot of talent to basically develop his algorithms. Any questions? Anyone? Am I losing anyone? Unfortunately, it's you're looking through a very small little window onto everything that's going on. I'm just going to give you a rough summary of everything I know.
So I might have missed it at the beginning. This is a very specific sort of
Architecture.
thing. Right. So how did you get interested? How did you discover this and become interested in it?
Well, I guess the big thing is at FedEx what I'm doing is health status monitoring, and also basically doing a lot of displays and graphics for services and looking for loads. Like, for example, I used to work on something called in-flight shipping service, and we keep track of how many packages have been redirected, and also it's also used for monitoring the health of services. If our load is anticipated to be such and such and it's not such and such, maybe it's indicative of a problem. And so I've been looking at these charts, and then I stumbled across a demo that he has. The company has a product called Grok, and Grok is their anomaly detector for network trafficking. And so I kind of thought that's very close to what I'm doing right now, and I kind of stumbled across it, and it's it struck me as interesting right away. But then all of a sudden it became even more interesting because I could try to sell my ideas and whatnot, and maybe we'll try to license it. Okay, maybe we'll try to license it at FedEx and use it for our own anomaly detection. And there's probably even applications for fraud and things like that you could begin to use algorithms like this. All right. I have this little presentation I wrote up. My daughter says, "Oh, you should have more color view charts and PowerPoints," and I should, but those things take so much time spent futzing. Oh, the font is wrong, and yellow clashes with it's not like the old days where you went up to a chalkboard and just wrote big pictures. And do you still do that at school? No, you do it on whiteboard. Yeah.
I can't spell and I have really bad handwriting, so I tend to do most of it on screen if I can help it, just for the students' sanity.
Yeah.
Is it still chalkboards or are they all dry erase?
We actually still have a bunch of chalkboards floating around in the buildings. I don't know why.
Until they get, completely. All right, and now if you also go to this GitHub site and you sign on, you basically get you basically can download VirtualBox from Oracle. And then in VirtualBox, they have an image in Linux, and they also have images and other things. They have it for, I think, Leopard for Apple, and they also have one for Amazon Cloud Computing, whatever they call it, whatever their architecture is.
You talking about NewPick just has ready to go?
Yes.
Okay.
They have ready, and with Amazon, it's actually a subscription service. So yeah, and if you have your own Amazon cluster and things like that, you can port it to. But nice thing, so I didn't have to spend too much time.
So it looks like they have some Vagrant boxes.
Yes,
Is that what you use?
exactly. That's what I use. I use Vagrant, and I learned more about Vagrant than I ever knew 2 months ago.
Vagrant's awesome.
Yeah, actually, give me your name. I need a contact list when things don't work.
Yeah. Joe Ferguson.
Okay.
Vagrant master.
All right, man. you will regret opening your big mouth, okay?
No, hey, no, I'm not Joe. I go to Joe for all my vagrant needs, because he's like the vagrant master.
Oh. Well, you know, you learn by doing things incorrectly.
Honestly though, if you have problems with vagrant, Joe will know the answer like off the top of his head.
Oh, that's awesome, man. And they also have a Windows offering. They don't really support it, and they use Sigwind, and it's kind of buggy. And also, there's things about the way that the code comes out of the. I think there's something about. I don't know if it's as simple as the carried return line. There's some things about the way it's formatted. You have to have a little thing that reformats the code, and I don't think it's just carried return line free convention. It's a little bit more. I think it's the way that I don't know. There's little issues about it, but you can develop on Windows if you feel like you want to chase your own problems. Okay, and you know, I tried running it on a couple of things. I tried running it on, if you go to the YouTube video, they have what's called basically they spit out a sine wave, and then they try to do predicting of a sine wave. Well, mathematically, that's harder to do than trying to predict any sort of silly pattern, because if you know, like from Taylor's formula, a sine wave has basically an infinite number of constraints. If you remember, you know, the Taylor series expansion of a sine wave. So what happens next depends on a lot of factors to get a nice sine wave. So if you go to the tutorials, he has a bunch of them that basically go out there and try to learn, like he calls it the hot gym example, and it's basically the power consumption in the gym, and basically you see that 8 o'clock, or from 6 to 8 is heavy duty consumption. There's less consumption, then it's shut down at to 9, 10 o'clock at night. But 2 in the morning, the crew comes in there and they clean up, so they power all the lights on and use electricity, and then they shut down. And so basically he tried this algorithm out on this power consumption. I tried to replicate the results. Unfortunately, I had a couple of problems. The problem with open source is that everyone's throwing everything in there, and not everything gets tested. And also the other thing is that this modeler, what it does is it formulates guesses as to basically it holds on to estimates of this intermediate layer knowledge, okay, and then it evolves this knowledge. However, that very much depends on your initial guesses, and it also depends, if your initial guesses are close, you tend to converge. If your initial guesses aren't, you're off in the Netherlands, and you might not be able to get the same results. And also, the image that's there is dated. It's a year old. It's March of last year, so I haven't quite been able to synchronize all my code to their latest code base, so. And I only have a certain amount of time during the day to devote to this, so it's been a lot of work. I tried here, actually I was doing this earlier today. Unfortunately, I basically managed to crash the algorithm, and basically what this is FedEx's stock price for the first 2 years in existence, and the blue is the actual price, and the red is the algorithm's estimation of what the next day's stock price is. Now, algorithms only like this work if there are inherent patterns that it can detect, okay? A lot of stock market patterns that people saw in the past tended to be driven by the agricultural cycle. So, the harvest is in the fall, so everyone's making a lot of money, and then afterwards, people are... So, the market had cycles to it, but after a while people began to hedge and do all sorts of stuff. So by hedging, they're able to, you basically buy futures and contracts for commodities you don't own, and so that really messed things up. So, and also this sort of pattern can't detect external influences that aren't in the data. So if something happens tomorrow, if an earthquake strikes California and California goes down into the ocean, it won't be able to predict discrete events that are influenced by factors outside it. It'll only pick up patterns that are in the data. that's why he liked that example of the gym usage. It was simple, you know. It had certain patterns to it, you know, coming on in the morning and then, you know, 2 major clusters of usage. And also, you know, it depends on how much of the windowing you do on the data. You know, are you trying to pick up patterns in time frames of months, or are you trying to pick up patterns in terms of years? And so you have all this stuff that goes on. Yeah.
So in this example, what was the training? Did the training data look like?
Well, the training data, it basically looks at the previous thing, and then it was only a one-step estimator.
So it was doing one at a time.
It was one, yeah. So look at the previous data, and then estimate one day in the future, and so basically, yeah, it would basically see. There's no data point at the first day. Okay, there's no knowledge,
Right.
and so over here would predict that, and so. And also, this isn't a long enough time. I mean, you need 1,000 data points to really form a good, a robust training example. However, what happened is like the thing crashed. Man, I was trying to run it for 2-3 days. It kept crashing on me. So, you know, and then there's like you can tell it crashes because it doesn't bring the platform down, but it basically it maintains a metric as to how good it thinks. It's estimated. It's called the anomaly detector or anomaly error, whatever. And my anomaly error was infinite, so
Okay.
I knew things were just completely wrong. And also, there's probably a little bit more. And I'm trying to do this for 20 years out. So I'm going to try to see if I can see patterns, and I'm also going to try to see if I can fold in extraneous information, like looking at government statistics on trade with China and other people, and try to get a sense of, well, if you're trying to estimate FedEx's stock price, one of the big influence factors is how much trade there is going on in the rest of the world. And now I'm also going to try to fold that into estimating our workload. So using as external factors, so you can think of this as, back in the model, you'll have certain models that are doing stuff, and then you try to communicate all that information and see if, you want to see if these learning modules will couple or if they're completely decoupled. And I was reading a little bit, the algorithm is open to development, so you can go in there and tweak it. I guess his only restrictions are that if you want to check code back into the repository, it has to be a biological inspired idea. I guess he was too fed up with being his work, beaten over the head for the last 20 years or 30 years. So it's got to be biologically inspired and make sense from a biology standpoint, which leads to itself, maybe there are hybrid algorithms that people are going to be interested in, which are, completely, transgenetic, but people will find, well, I can do this, and if in the next 100 years we're designing intelligent machines, they're going to probably exceed our intelligence, and then we'll have to, they'll have to work in ways that our minds aren't working yet.
But so he's trying to preserve the integrity of it as a neurological analog?
I think he's probably more concerned that he doesn't want it going off the straight because he thinks that nature is still the fundamental driver, and we don't really understand that. And I think it's historically, he had a lot of people reject his work because their own neural network ideas were front and center, and they were getting a lot of attention, and they were taking away any research dollars or any sort of interest he had. So now he's got $50 million to play poker, so he's going to be his game, baby.
The gym lights example reminds me of something Google does, which is it knows where I live, presumably because it sees that I sleep there.
Yeah.
And the reason I know this is because, like, if I type home into Google Maps, my address is 224, when really my address is 226, and I never would have put that in anywhere. So, like, at some point, Google realized, like, this is where you live, this is where you work.
Yeah. Actually, I noticed that my wife noticed the same thing.
Yeah, it's a similar idea.
Yeah, so where's your phone spending?
And also just like, it seems so simple, but like, I went out of the country and like I had a whole stack of Google notifications to navigate the places that we mentioned in emails between me and my brother-in-law and currency exchange rates and all that stuff. So
Wow, yeah.
even though it seems simple, where like, okay, he's landed in this different country, let's spit out these like canned notifications. It makes sense if there would be something like this behind it driving.
Yeah, and also, you know, you're driving to the airport or you're driving to places that indicate that you are going to go someplace else. You
Right.
know? You don't drive to JFK because you want to watch planes land.
Or like, you know, Google like the library at work, and then you get in the car and there's a notification for it. I think we're starting to take that kind of thing for granted.
Yeah.
Because but it's really just gotten good over the past few years because of these.
Well,
Does it use a neural network to do that though? Do you know
I mean, it seems so simple, but then again, it is Google. I'm sure they have some sort of crazy artificial intelligence driving everything, but
just pay some
Lots
guy
and lots
in,
of
like, another
cookies.
country to-
I mean, the
read
gym
it.
lights example really reminds me of. When I realized where I lived, that was a big like.
aha moment.
Yeah, for me that.
So out of curiosity, have you seen, oh, go ahead and finish.
No, I'm done.
Okay. Did you see anything that talked about people adopting it? And the reason his concept and actually implementing, because there's an article on, what is it, InfoWorld a couple days ago, I think 13th or something like that. And the title was, Big Data is simply another name for complicated business intelligence. And it's talking about the continued, almost aggressive deployment and acceptance of all these big data solutions, Hadoop, whatever else. But, hey, we got all the data, no one still knows how to get the answers out.
Yeah, and actually, well, with FedEx, people talk about there's so much data out there that what you need is, you know, what are you going to do with all this big data? I mean, you can't possibly store it because next year there's going to be 3 times, it goes up as geometrically. So every year you have twice as much data as the year before, every year and a half. So what you really, the application is to have sifting, you know, is to basically look at data and sift out knowledge and collate that knowledge and store that knowledge in a simpler representation and throw away, you know, 99.9% of the data and just keep the raw statistics and the raw merits. And I think that in my presentation there, that's why I started off, but you know, it's hard to talk about everything at the same time. But yeah, it's all driven by the fact that, you know, big data is here, and you know, one good application is to basically develop pattern recognizers. You know, are there any patterns that you can pick up? You know, everything from customer to, you know, traffic light. And if you go to if you look at some of the hackathons, they'll go out there and you know, people try all sorts of ideas that, you know, some are from a novel and some are from completely off the bat, like the one with the music example. You know, that was interesting because that was something they never thought about. And I think that's, you know, by giving this to, you know, as an open source project, there are a lot of applications that, you know, companies, I remember, I can't think of a good example, but I was talking about this CEO of a company, joked off, well, I have a great idea here, now I gotta find, and I gotta sell it to somebody. And I remember even the other thing that, Velcro, you know Velcro? Well, at first the guy talked about trying to sell Velcro to people and saying, no one really wanted to buy it because he just thought it was a stupid idea. Well, why do you want that? And it was also a biologically inspired idea because he had a dog and he would take his dog out for walks and his dog would pick up the burrs, you know, are they common in the South here? Those little balls with little things on them, and they'll catch onto your skin and catch onto, like, especially dog fur. And then you pick them out and you got an idea, hey, why don't I make a product out of this?
Okay.
And then, so it also, you know, a biologically inspired idea. So, let's see, what else can I say? And basically, I went to the, I don't know if I have my internet, I probably don't have a connection here.
Oh yeah.
I was gonna just, you know, does that work? Co-work partner? Am I a co-work partner?
Yeah, the password is cowork. Once you, all one word, the first letter is capitalized.
Co-work wants you. Okay. First
Getting back
letter.
to the address issue, most of the companies take data from USPS. Where do the person live? They have API. The USPS has the biggest master data.
That makes sense.
It's easier for them to find the people where they live.
Yeah, that makes a lot more sense. The thing that got me was the 224.
It's easier because they know your email address, they know your name, they know the city you live in, almost the road, except it's the number.
Right. That makes a lot more sense. I want to believe, man. You kill my dreams.
They're definitely
It's
using
magic.
location data to model your behavior. I know with my
Sure.
Google Now, I go to Molly Fontaine's lounge often, and so Friday afternoon comes around and it starts to remind me. It says Molly Fontaine's is 7 minutes away and gives me directions and things. I certainly never told them I went there.
It also says like 5 minutes to work and stuff like that. So it knows where I work.
Yeah.
Well, not only that, but like, it knows that I use public transit a lot, so.
It gives you the, yeah.
Instead of 5 minutes to work, it's like 30 minutes to work if you leave now, or, 50 minutes to work if you leave in 10 minutes.
Actually, well, another thing is I found sometimes it thinks of ideas before you do. Now it's getting to be sophisticated, and it's not that, it thought of it. Someone else thought of it, and that query's been entered 100,000 times already, and it's like, if you want this, you also want that.
Yeah, that was like the biggest sort of aha moment, like you said, for me when I went to Bali, and one of the things on our itinerary was climbing Mount Batur, and when I landed, I had like a navigation notification to Mount Batur. The only way I would have known that is because my brother-in-law had sent me an email that mentioned Mount Batur, which I had never heard of or talked about before. So that was pretty cool. But yeah, like when I saw it, I'm like, yeah, that's useful information. I wouldn't have even thought to look that up, but Google thought of it first. So.
Well, someone else thought of it, and it's been entered so many times in Google. It's climbed up the popularity list. And actually, I was looking at you guys ever go out to Coursera? There's a website called Coursera.org, and Andrew Nung, this guy, basically he teaches an artificial intelligence class, and it's really good. I mean, it's just an awesome class. So this is my GitHub site, and I had a GitHub account, which was basically I did some work in CAD/CAM, and I basically put that on the GitHub site. But now I joined Numenta's, and I'm trying to basically.
Now you right-clicked it.
Okay.
Did I not click that? Oh man, what's the matter? Fat finger. That's another expression. You ever hear of fat finger? So and I came out, I guess, traders and hitting extra zeros or hitting zeros when they're selling assets and basically having major catastrophes. And also, what kind of happened is that the opposite, I guess, maybe with computer intelligence, there'll probably be safeguards that'll basically, this seems like it's way out of range. Are you sure this is what you want to enter as your bid on this item or things like that? So, this sort of algorithms have 1,001 applications. And, I asked my boss to go out to California in October, and he's, no, that's a waste of time. I couldn't get money out of him, but, But actually, I was almost thinking of, doing it myself. I mean, what's a couple $100, and just, if you go out there, you'll resolve a lot of, build and issue and configuration problems just because you're there, trying to do it, you're doing it in an environment that, other people figure it out and have done it. There's like 150, I guess. I'm the one of the developers that signed the licensing agreement to this, so who knows what I did by doing that. But if you just want to download the code, I think you don't have to specify user ID or anything like that. It's only if you want to contribute. And I think that's only changed in the last year. I think, a year ago when I signed up there, you had to sign you didn't have to notarize it, but you had to sign it and mail it to them. And then when they got it, they didn't check to see. I guess, I could have used my daughter. She could have forged my signature. And it's not legally binding because I didn't do it or something. All right. Well, I chewed up a good hour of your time, and I mean, I can do more examples, but it's still all up in the air, and I'm still working and learning all this stuff.
Does it have any existing applications?
The stock market example to me was interesting because that looked pretty accurate in some ways.
Yeah, well, unfortunately, if you like, one
bad.
thing you notice in the estimates, it just used yesterday, early on, it just basically, if the stock market was 90 cents for a share, it would do 90 cents. But after a while, it would do a better job. And even with the sine wave, actually, I have a picture of that sine wave here. Hold on, let me see if I can bring it up. And I was trying to replicate this guy's results. Let me just go to, oh gosh. I'm just going to show you the sine wave. I couldn't get it as close as he did, and I wrote to this guy, but then he says, oh, I'm busy. Go figure it yourself. Hold on. This machine is, and the bad thing is that now this thing is like pegged at 99%, so you get a very sluggish response. I should just have a dedicated machine just to this. Let me just go here, here. Yeah. So this is the sine wave, and now this is after it's been teaching. This is the last 100 days of a 1,000-day learning pattern.
Okay.
So you can see the smooth thing is the sine wave, and the little glitches are where we would misestimate. So it's doing a pretty good job.
How many neurons does it take to do
this one? I don't know. He has like 3 settings. It has small or debug, medium, which is what you're supposed to use, and then the large memory pattern. And basically, he kind of doesn't tell you how many you have, and you really have to get into the sophisticated. There's 3 APIs to this stuff. So, I'm using the idiot API, which is, you just feed in data and then you say, you want to do it. You do it with a small example to kind of see if it works, and because you'll have problems, and then you have to figure them out, and then you went in a large set, and then if you want to wait, medium, and if you want to wait a long time. But I'm guessing it's probably tens of thousands. I mean, this example, I'm guessing it took about 10-15 minutes to run it through all the data, and I don't know what. And also it's restricted on your machine. It's also restricted on how many CPUs you have on your machine. So it's all parameterized, and unless you really get into the nitty-gritty parts of the algorithm, it's all hidden from you.
Okay. The training data, though, is just one value in this case?
Yeah, this one is just, it's the angle and the sine.
Right.
So the angle is the input and the sine is the output, and it's a one-step ahead predictor. Yeah. It has entries. You can do multiple predictions, so you can do like 1, 5 steps, 10 steps ahead. And he also talks about, issues with like data saturation and also the opposite. Doing a very coarse sampling. So if this is a sine, but you chose things that you chose them 100 units apart. You chose them like, let's say pi radians apart. You're not going to pick up a pattern because it's going to have to be less than a quarter of a pi to be able to pick up even anything on this. So and like I said, there's 3 APIs to it. There's the simple one, then there's the more complicated, and there's the third one. And also, I think that it's not all consolidated. The core algorithm is in each of the 3 languages, but then there's additional tools that they have developed. Like one of them is a visualization tool, and it shows you the activity. Well, with this the way that the wiring is done, and basically the way that patterns develop in the data, they have a set of tools that see it. But, I really didn't understand. I mean, I saw that it's a pretty picture, but I really didn't see any patterns that I could like identify. So, but they're developing tools to help them manage what's going on, and those aren't available in all libraries. Their primary development environment is in the Well, it's Apple machines, and I do it in Linux. So Linux doesn't receive the same level of support as they do it for the Apple, and probably even less for the other platforms. But it's all Java. It all should behave identically. But it comes down to tools and configurations, and if you know Cygwin very well, then it's probably not going to be an issue. But if you don't know it, then you're going to find all sorts of bugs, and you have to iron them out before everything works. All right, anything else?
Do any kind of commercial companies use this?
Yeah. He publishes his company, and he's probably got a dozen companies that he says that he's got partners, and he's probably got. Oh yeah, the other thing is you can do this in software, but he got a DARPA grant to develop these computational blocks through a DARPA grant, so he's basically having it developed in hardware. I'm sure the NSA and other people are terribly interested in, developing huge things in hardware. Behave. Hardware will compute 100 times faster than software today. So you can do a lot more things in hardware than you can do in software still.
Question.
Oh, yeah.
So this sounds like it's a very good out-of-the-box neural network.
Yeah.
But is there a particular advantage to using this type of neural network? Like you mentioned, this was derived from human sensory. So when you have a lot of data that's similar to that, is this better than other neural networks?
Well, it's all an opening question. I mean, it's still very much research. At this point of the game, it's research. I think the other thing that's probably going to break out of this this is successful, and he's making claims that within 5 years we're going to have true machine intelligence with this approach, and that's a very ambitious statement to make. And he's not a quack, he's not some guy, trying to sell you stuff.
My question.
Well, he got funded by, he just raised some money, so I guess.
Yeah,
he's on something.
But he's got a reputation. He isn't fly. He has too much to lose by making you guys listen to Kurzweil. You know who Kurzweil is, the big daddy of artificial intelligence at MIT, Marvin Minsky's student. I used to live in Boston, and we had a lab right next to Kurzweil Labs. Kurzweil Labs got its big start because they basically designed a synthesizer for Sammy Davis Jr. that was high fidelity synthesizer. But Kurzweil, if you go on, he's a big AI guru, and he's basically predicting the singularity, by 2030, 2040, saying that he's saying look at the development of look at the computational development that's been going on, and look at Moore's law, and then basically seeing how much computation you have, and it's going to be asymptotic by 2030, 2040. So we're going to have the knowledges that machines will basically be at a point where they can surpass us. There's two speculations about that I don't like. The first one is that past behavior isn't an indication of future behavior. Just because it happened in the past, it's not going to. And second of all, we're going to hit against certain limits that are going to be restricted by the physics of the situation. And also, things don't scale up. I mean, we're not building buildings the same way we build teepees or little huts, okay? So there's going to be, you take a certain architecture, you keep making it bigger and bigger, suddenly it's going to collapse. And so that sort of thing is going to be a big indicator. He talks about the reason that we're getting so much productivity turnaround is because we're using, each generation of computers that comes out there is used to design the next generation. So we're able to do it in less and less time than we were able to do it in the previous one. But we're going to reach basically a free fall state where the transfer of information from the previous generation to the next generation is going to become a limiting factor.
So go ahead.
Send me email. I put my name on the notice, and I also put a link to my page, which has parts of this write-up. So, but go on.
So you've used the term a couple of times now. Back in the, I'd probably say early mid-90s, artificial intelligence was touted everywhere, discussed everywhere. It was the answer to all of our business intelligence problems.
Yeah.
Blah, blah. And as we got through started getting into the late 90s, there's actually a conscious move away from that terminology.
Yeah.
Because of people not being comfortable with the concept of, and I joke with my students, of Skynet.
Yeah.
From Terminator.
But that's all.
And so I'm wondering, are you, as you're reading about this stuff and whatnot, because I've not followed that anytime recently, is it actually starting to come back into vogue a little bit? Or there's another term they started using, and I can't remember what it is. I've been trying to remember for a while now here.
The singularity?
No, for instead of using artificial intelligence.
Machine learning?
Yeah,
Deep
they
learning,
started
machine
moving
learning.
it towards machine learning, but for some of the predictive stuff that they would try to do, there's another term they're using that's real popular in the early 2000s.
Well, you know, the other thing, I look at these algorithms and I say, oh man, this is just the marketing department's moved over to the comp sci department.
Yeah.
Because, you know, a lot of these algorithms, they're really not machine learning. It's basically applying, I guess, you know, concepts. If it was a math department, they'd come up with a, you know, a predictive analysis based on, you know, so-and-so. It reminds me of a joke I read years ago. It said, you know, you go to the bookstore in a school library, you know, campus library, campus bookstore, and you go to the management section. It's advanced principles for, you know, management and you know, future business, you know, all these high-sounding things. You go to the mathematics and physics departments, elementary particle physics, a first introduction to abstract algebra. You know, have you ever taken a class? I've taken the class. You know, an introduction to abstract algebra. There's nothing introductory about it. Okay, it is just mind-numbingly beats you up and everything, and left idempotence and right idempotence aren't the same. It's like, man, I never even realized that. And you know, I went through undergraduate training in mathematics, and then I went to grad school. And the first thing they did in grad school is tore everything apart in undergraduate. And they talked about, you know, as much as quantum physics wreaked havoc on classical physics, the same sort of thing happened with mathematics. Probability theory wreaked havoc on classical mathematics, and so they had to reformulate mathematics with Lebesgue integration, and you give up integrating by the x-axis, you start integrating at the y-axis, and you look at sets that all fall into this, and measure theory, and you know, and then all sorts of weird stuff starts entering the picture that, you know, people never thought about before. And, you know, and the same thing with, you know, this sort of thing. You know, it's all still new stuff, but you know, there is that marketing glitz that people tack on to things that, you know, wow, you can impress people who don't know what you're talking about.
So I'll jump in so the field of machine learning, and that's the term that a lot of people in like West Coast tech industry is calling this.
Yeah.
But it's people with that set of skills are super in high demand. And
Yeah.
Oh yeah.
so that like data science is
Analytics.
Oh, I read some of that.
Bayesian statistics in any that's all over the place.
Yeah.
Like Google's first iteration of PageRank was really just a simple Markov model.
Yeah.
But like all the ad tech is all statistical Bayesian statistics. And it's all like they're throwing all sorts of machine learning algorithms at that still in order to just like get little tiny incremental improvements.
Well, you know, the other, I saw a quote to this effect that Johns Hopkins runs a machine learning master's degree program, and apparently it's much more difficult to get into Johns Hopkins master's and PhD program in machine intelligence than it is to get into Harvard Medical School. And I guess, you know, salaries of that start with at $200,000 a year, and you know.
So this is kind of interesting. It's artificial intelligence versus machine learning.
Yeah.
Looks like they just crossed.
Yeah.
But Yeah, it's like artificial intelligence is like significantly dropped off. This is just 2005, but
What is that? How often it's talked about, or?
yeah, Google lets you switch between like searches and field of study and like several other things. Like one is a 2001 film. So that particular chart is search terms. So that's people searching for artificial intelligence.
Well, but you
It's
know.
interesting.
But you know, the other thing is, you know, I'm sure that there's even other things that happen. Is that as soon as you start calling it, you know, cortical learning algorithm or what's it called, hierarchical temporal modeler, then you know it breaks off and becomes its own subset. You know, people used to joke around that until the '60s, you know, computer science was in the math department, and now computer science is bigger and its own department, and you know, so. All right. Any other questions? Discussions? And you know, this is a work in progress, so I hope to. This is my first time I made this presentation, and I also mess things up. Don't try to reinstall a new Vagrant build the night before your presentation. You'll never see the same. You know, someone had a good quote. Is that working software is terribly underrated. You know, because it works, and then you decide I'm going to make it even a little bit bigger, and you do something and you don't know what's wrong. And another one of my friends used to have a quote: "No amount of software engineering talent, money or talent or time will outperform a well-rigged demo."
So I have a question.
Yeah.
So this has been really interesting, and like I'm curious I'm kind of curious what you want to do with it next. Like,
okay,
where are you going to take this?
Well, the first thing I'm trying to do is tie it into predicting. Okay, actually, as inputs, I want to be able to predict our volume at FedEx and have input as previous historical behavior, and second of all, FedEx's stock price, because it's it's correlated to how much volume we do. It depends on our stock price, which is, you know, maybe it's the other way around. And then the third is this other statistic to basically look at government trade statistics and look at databases and pull that information out and kind of use that all to predict what's going to happen. So right now I'm just predicting volume within FedEx.
But so since it is a neural net, and if it learns something,
yes,
you can't necessarily know what it learned.
Oh, that's getting to. Actually, I have the opposite problem. There's things that I know, and I kind of want to help it along, you know, and I'm trying to think of how to formulate things so that I can help it along. And right now I'm kind of doing it in the data, you know, I'm trying to piss around with the data and come up with some, like, I'll come up with my own averages and then have other statistics which are basically deviations on those statistics, and kind of, and then have buckets for like holidays and things like that, and then use that. So I'm trying to do it at the data formulation level, but it would be nice if I could just go in there and somehow tell the stupid algorithm, okay, Thanksgiving is on the 4th Thursday of the month, so there's going to be very little volume that happens on that day. You know, Christmas, okay, Christmas is you know, you can predict Christmas. Yeah, it picks up Christmas. It picks up that, you know, trot and data in Christmas, and other
But
things.
it doesn't pick it up because you told it.
No, right.
December 25th is a big
But it's
day.
because it's periodic.
Yeah.
Okay.
You can make that into an input data, sir.
Well, real quick, is that some sort of plug-in mechanism where you could like theoretically write something that's
Well, all of
when all the holidays are?
Yeah, and I'm trying to do stuff like that.
Yeah.
And also, there's several ways to approach it. I mean, there's you know, trying to get into the algorithm, and there's a couple of ways to approach it. I'm still kind of, you know, running around trying to figure out what's going on, you know. And hopefully, you know, I'm going to do a presentation like this. I would like to do it at the Python. Actually, after I saw the Python list, who's the one at Python? Because all this stuff was in Python. My biggest problem was Python, man. Just the indentation and knowing that the indentation and having, you know, you read a file in, your tab settings are incorrect. And it's like, what does it do about tab settings versus hard spaces?
They're different. Yeah, white space is significant. So most the Convention is don't use tabs, use spaces.
Oh, well, no. You know, when I write my own code, I always turn, you know, in Visual Studio, I don't use Visual Studio, but in Visual Studio, it'll have an option to turn tabs into turn the spaces.
Right.
And I always do that because that way, if you open up in
Turn to